हाँ यस सो लेक्चर नंबर 18 स्वागत है सभी का भाई. वेलकम एवरीवन. ओके, so basically I had forgotten to because some student from Tamil Nadu and some students from Mizoram, they were very angry with me that you always speak in Hindi, we cannot understand. So that's why beta, for you especially for you, these lectures are being made in completely English. Okay, because you were not able to understand it properly, but sometimes I really forget that, so sometimes Hindi comes out of my mouth, so really sorry for it. Okay, so let's move on towards our next this thing, problem. Okay, we are discussing basically problems, so now one more problem we will discuss. Okay, now so some of the people from North India are very angry with me because I don't speak Hindi. Okay, some people from North India, they are very angry with me. Why? Because sir, you are teaching in English, so we are angry. We want Hindi. Okay, we want Hindi. And some of the students from South India and Northeast. Okay, South India and Northeast students, they are angry with me because I was making the English videos in Hindi initially. Initially, I was making the videos in Hindi, so these people were angry, and please English. These people were saying. Okay, so my simple thing is that I can't do anything. So I have basically I am making the lectures in international language now. Okay, so let's make the videos in international language only, because if I teach in this language, then these people will, this language everyone can understand, even a North Indian student, can understand this language. Okay, so my request to North Indian student is that please continue with English, because otherwise it will be where will I go then? I can't I had tried to launch 3 courses in 3 languages. Okay, I had tried to launch the courses in 3 languages, but I was really falling short of time because of that. So I just quit that. So that's why I would say to the my appeal to the North Indian people, that please watch the videos in English. I am speaking nice English. Okay, I am not speaking very confusing type of English. I am speaking nice English, so you will be able to understand this English. And you are writing the paper in English medium, right? You are writing the paper in English medium, so you must not have any allergy with English. Okay, you are writing the paper in English medium, na? So that's why you must not have any allergy for English. Okay, you should watch the videos in English only. Okay, so from now on the videos are going to be in English only. Only those videos related to, only the strategy videos, only strategy videos and personal videos which I make, some chit chat type of videos, those will be in Hindi. Okay, chit chat videos and strategy videos, those are going to be in Hindi, but rest all of the academic things will be in English only. Okay, so don't worry about it. Okay, so let's and the problem is that a person in North India can understand English, but the vice versa is not true. South Indians and northeastern people, if we do the survey, then only 70% of northeast people, only 70% of northeast people and South Indians are able to understand Hindi. Only 70% are those who are able to understand Hindi. 30% can't understand Hindi. Okay, so that's the problem. So that's why I am making the videos in complete English. Okay, so don't be angry with me, and please don't make a hue and cry over the language. Okay, so that's all I can say. So the normalized state of a free particle. Okay, let's write over here the normalized state. Okay, the normalized state, and again of a free particle. The normalized state of a free particle is represented by a wave function, by a wave function. And I would like to recommend to South Indian and Northeastern people. Okay, my I would like to recommend to these people that beta, please learn Hindi. Okay, learn Hindi, beta, learn Hindi. Why should one learn Hindi? That's because it was the dream of founding fathers to make Hindi as the national language. Okay, it was the dream of the founding fathers of the nation that Hindi should be the national language. But because of some of the groups, this can't be fulfilled. Okay, because some of the people from South India and Northeast especially, they opposed. Okay, so you should learn Hindi. Why? Because Hindi is the only language. Okay, it is the only language in India. This is the only language which 75% persons, 75% of the population of India can speak this language. Okay, 75% population of India can speak this language, which is Hindi, and 95% of the population of India, okay, can understand this language. 95% are able to understand this language. 75% are able to speak this language. Okay, so learn this language. I would recommend you. Okay, and this will also be helpful to you, because if you are from a person from Tamil Nadu and you qualify the UPSC exam, you become an IAS officer, then you might be posted at Uttar Pradesh also. Okay, a Tamil Nadu person can also be posted at Uttar Pradesh, and if you are posted at Uttar Pradesh, then you will have to speak Hindi. You will have no choice, because your office people might not understand English. Okay, so that's why you should learn Hindi. Okay, so the normalized state of a free particle is represented by a wave function. This is the wave function psi x comma 0, okay, is equal to ne minus x square by 2a square, okay, plus iota k naught x. Okay, so this is the normalized state of a free particle, and it is represented by this particular wave function. Okay, so we have to basically find the normalization factor n. In the first problem, we have to find the normalization factor n. Okay, normalization factor, you have to find the normalization factor n, and the second part of the problem I will write in later on. Second part of the problem I will write later on. So see over here, b part is also there in this question, but the b part I will write later on. Okay, so the normalized state of a free particle, okay, normalized state of a free particle is represented by a wave function. Okay, normalized state of a free particle means this is basically just for the sake of time pass, it is written like that. Normalized state of a free particle, it's not like that, nothing of that sort. It's only that wave function is represented like this. Okay, you should consider it like that only. Okay, so normalized means it is normalized, and wave function will always be normalized only, na? If it's if suppose a wave function, if in case it satisfies the Schrodinger wave equation, then that wave function will obviously be normalized, and this is the solution of Schrodinger wave equation, so it will be obviously normalized. So the statement given over here, the normalized state of a free particle, this does not make any sense. Okay, this part is just for senseless giri. This part is just for senseless giri. Okay, so psi x comma 0 is equal to n e to the power minus x square by 2a square plus iota k naught x. Okay, this is the thing. So find the normalization factor n is the thing which has been written over here. So how to find the normalization factor n? I had already told you in the previous classes that and what is this kind of wave equation? Wave function. It is time dependent wave function. Time dependent wave function, but the value of time has been put to be 0. Okay, this is time dependent wave function, right? Because it is being represented by capital psi. As it is being represented by capital psi, so it is time dependent wave function, and the time dependent wave function is such that we have put the value of t equal to 0. Okay, how does it look? It looks like this, right? Capital psi x comma t, it looks like this. Capital psi x comma t, it looks like this. So you will put t equal to 0 over here, and if you put t equal to 0 over here, you basically get this thing. You basically get this function, which remains a function of x only then, because you have put t to be a constant. So at time t equal to 0, at time t equal to 0, this is how the time dependent wave function looks like. At time t equal to 0, at time t equal to 0, this is how the wave function, time dependent wave function looks like. At time t equal to 0, this is how the time dependent wave function looks like. Okay, so you have to find out the normalization factor n, okay, which is called as n. So now we will apply the normalization condition over here. Okay, so the normalization condition is, okay, the normalization condition is, integration minus infinity to infinity, okay, psi star psi dx, right? I had already told you that how this came. This basically came from that formula. I had already told you that for the normalization condition, we basically take this formula, right? In the x direction we integrate, in the y direction we integrate, and in the z direction we integrate. That is basically called as volume integral. Right? That is basically called as volume integral. I had already told you in the previous classes. Now this is the volume integral. What is this? This is volume integral. And this is volume integral. This will be applied when it is three-dimensional wave function. When it is three-dimensional wave function, then this formula will be applied in the case of three-dimensional wave function. And this is what basically, this is a volume integral. Okay. So you must have learned triple integration or volume integral in your lower classes. Not in lower classes, in BSc you must have learned it. Okay, so d tau is basically your dx dy dz. Okay, dx dy dz. Okay, so d tau is your dx dy dz. So this is basically your volume integral. This is three-dimensional wave function. Okay, and if we convert it into one dimension, suppose I want to convert it into 1D. So how will I convert it into 1D? This is the way I will convert it into 1D. Suppose only x direction exists, y and z direction do not exist. Suppose so only x direction is existing. So clearly I can write it like this. So normalization condition will look like this. Okay. Now look over here that your psi is looking like this. Okay, your psi is looking like this, and your psi as it is looking like this, I will put the conjugate value over here. Now let me write the psi properly over here, because the psi has been completely splashed off. Okay, it is completely splashed off with colors. So as it is splashed off with colors, let me write it over here once again. So e to the power minus x square over 2a square. This is the wave function which is given to you. I cannot x. Okay. So now we will basically find the conjugate. Okay. So if we try to find the conjugate of it, what will it look like? I had already told you that in order to find the conjugate, you must replace iota by minus iota. Right? I had already told you this. So you will replace iota by minus iota. So you replace like that. Now you will put these two values. These two values you will and n will also become n star. Okay. This is n. This n will also become n star, because that is also a complex number. Your n is also a complex number. Okay, as your n is also a complex number, so basically it will also have its own conjugate. So that's why n star will come over here. So you can put these values inside this, and if you put these values inside this, basically you will get something of this kind. You will get something of this kind. Okay, n star e to the power minus x square over 2a square. Okay, minus iota k naught x. Okay, and then again you will get n e to the power minus x square over 2a square. Okay, plus iota k naught x. Okay, and this is basically dx, because this is one dimensional. I have basically put these values. Over here. Okay, that's it, nothing else. Okay, that's what is written over here. So this value is clearly equal to 1, because the normalization condition is there. Okay, so basically now I can put this out of the integral, and n star n will be there. Okay, and this will be minus infinity to infinity. Okay, then again this term will be like this. Okay, multiplied by e to the power minus x square by 2a square. Okay, and what will happen to this? These and this will cancel out. Okay, so let me write over here e to the power minus I k naught x multiplied by e to the power plus I k naught x. Okay, is equal to 1. So basically these two terms will cancel out, because they will yield you 1. Okay, they will yield you 1. By laws of indices you will add these two. By laws of indices you will add these two, and when you add those two, e to the power 0 will come, and e to the power 0 will eventually become 1. Okay, so now when we add these two, now according to laws of indices, these will also be added. So when I add these two, basically I will get minus x square by a square. Okay, so what will I get? N star n. Okay, minus infinity to infinity. Okay, e to the power minus x square over a square dx. Okay, dx is also over here, I haven't written. Okay, dx is equal to your basically 1. Okay, so you must have understood this thing. Now let me write this once again, so that it becomes very convenient to us. N star n, this is what we have obtained. N star n minus infinity to infinity e to the power minus x square over a square. Okay, dx is equal to your 1. Now you know this very well, that I have taught you in the initial lectures. In the initial lectures I have taught you this thing very clearly. Okay, this thing has been taught to you very clearly in the initial lectures, that this result we have already obtained. So you might have learned this result by now. So I had told you to mug up this result. I had already told you to mug up this result. So in the place of a, just put 1 upon a square. Okay, so when you put a in the place of a 1 upon a square, what will happen? This will eventually turn to minus infinity to infinity. In the place of a, we will put 1 upon a square. Why? Because over here we can see. Okay, over here we can see, we can compare the a value, and it is coming out to be x square over a square dx, and again square root of pi by, okay, 1 over a square, right? 1 over a square. So this will basically become a root pi. Okay, this will eventually become a root pi. Okay, so your this integral is coming out to be a root pi. Okay, your this integral is coming out to be a root pi. So n star n, n star n, n star n, a root pi, a root pi is coming out to be equal to 1. Okay, so you know this thing very well that n star n, n is what? N is a complex number, right? N is a complex number. And as n is a complex number, you know this very well that conjugate multiplied by complex number is equal to modulus of complex number square. Okay, it's mod square. When a complex number is multiplied by its conjugate, we get the value equal to square of its magnitude. So you can put this thing over here. So when you put that thing over there, mod n square a root pi will come out to be equal to 1. Okay. So now from here, this is very clear that 1 over a to the power 1 pi to the power 1 by 2. Okay, and now you will take again the square root on both the sides. So when you take the square root on both the side, you will basically get a to the power 1 by 2 pi to the power 1 over 4. Okay, this is what is the modulus of n. And as you know this thing very well that magnitude of a complex number I have got, magnitude of complex number I have got this thing. So how will I find the complex number? The complex number will simply be equal to, the complex number will simply be equal to pi to the power 1 by 4 e to the power I phi. Okay, where phi is what? Your phase factor. Okay, phi is your phase factor. I had already discussed this in the previous classes. Okay, I had already discussed this phase factor etc things in the previous classes. They have been discussed over there. Okay, so now how we can verify that its modulus is equal to this? Its modulus is equal to this. We can clearly verify this thing. Use Euler's formula. Okay, use Euler's formula. If you use Euler's formula, what will you get? Cos phi plus I sin phi. So when you take its mod, what will it be equal to? It will be equal to cos square phi plus sin square phi. Okay, which will come out to be equal to 1. So your this thing has a modulus equal to 1 clearly. So when you take mod n, it will be equal to this. This has been verified now. Okay, this has been verified now. And this is basically nothing. This is nothing rocket science. This is 11th 12th JE concept. 11th 12th JEE concept it is. 11th 12th JEE maths. At that time you must have learnt all these things. You might have forgotten these things, but at that time these things used to be there in your syllabus and you have already learnt it. Okay, that's why they are being applied over here. There is no rocket science in it. There is no rocket science in it. So basically we had to find the normalization factor n, right? So this is what is the normalization factor n. This is how the normalization factor n looks like, because over here it has been written find the normalization factor n, right? It has been written find the normalization factor n. So that's how the value has come. Okay, that's why the value has come. So now we will move on towards the B part of the question. What is the B part of the question? What does it say? The B part of the question clearly says that in what region of the space, okay, in what region of space, in what region of space the particle is most likely to be found. In what region of space the particle is most likely to be found. Okay, so this is the thing. Now you know this very well that it is asking you the area of highest probability. What is it asking you? He is asking you the most likely to be found area. What does this mean? Most likely to be found means highest probability area. Okay, highest probability region. Highest probability region. This is what it means. Most likely to be found means highest probability region. Okay, so the probability density is given by, okay, the probability density. How is it given? It is given like this, that you might have learned that I had already told you by Max Born. Okay, we are using Max Born interpretation. We are using Max Born interpretation. So what will this turn out to be? X comma 0. Okay, square. Square means magnitude square. Okay, so what will this turn out to be? You can write it clearly to be equal to conjugate. Okay, and over here we have used the symbol small psi, but to be more appropriate we must use the symbol capital psi over here. To be more appropriate we must use that symbol. Okay, you must use that symbol. Okay, so now you know this thing very clearly. Okay, because it is time dependent function, right? So as it is time dependent function you must use capital psi over here. Okay, so you will use capital psi. Now this thing you know very clearly that we had already found out this thing, right? With psi star and psi value, the product we have already found out. Okay, psi star psi product we have already found out in the previous slide. You can see, right? We had found out over here. Where over here we had found out, right? It came out to be like this. It came out to be like this. We had already found out. So psi star psi product we have found out, and now this psi star psi product, it looks something like this. It looks something like this: e to the power minus x square over a square. Okay, this is the thing, and clearly this mod n square will take place. Okay, and e to the power minus x square. How this came? You know this very well, right? Complex. N is a complex number. N is normalization factor, but at the same time n is also a complex number. So as n is a complex number, so clearly n mod of n square will be equal to n star n by the property of complex number. So this is the thing which came out of the thing. And now we had already found out value of n square, mod n square. Okay, we had already found out the value of mod n square in the part A. We had already found out the value of mod n square in the part A. So you had clearly found out its value. So you will write, okay, 1 upon a root pi e to the power minus x square over a square. Okay, this we had already found out. Okay, so clearly we whenever such a result comes out, you have to discuss the result. And yet the question is also not yet answered. Okay, question is not yet answered. So at x equal to 0, what will happen to this? At x equal to 0, what will happen to this? We can clearly see that it will become 0 comma 0, because you will put x equal to 0 over here. So it will become rho 0 comma 0, means rho means probability density. So at x equal to 0 your probability density comes out to be this, and this will be maximum. Why will this be maximum? Because you know this very well. You have a look at this function, at this part of the function. This part is complete constant, this part is completely constant. Now have a look at this circled part of the function. As you look at the circled part of the function, you can see this clearly, that when you put x equal to 0, you will put it over here. So this will turn to this. But what will happen if I put any value other than 0? If I put any value other than 0, okay, if I put any value other than 0, then clearly if I put suppose plus 1, so it will become e to the power minus a by 1 upon a square. Okay, so if I put minus 1, then it will become again e to the power this only. Okay, so clearly as it is x square over a square, so this quantity is always positive. This quantity is always positive. And e to the power, so this quantity when we take its negative, it will be always negative. Okay, it will be always negative. So e to the power negative. Okay, so when e to the power negative is there, it will be like this. Okay, e to the power negative can be written 1 upon e to the power positive. And 1 upon e to the power positive, when it is multiplied by anything, it will become lesser, it will reduce. Okay, so in order to have our probability maximum, we must put x equal to 0. In that case this quantity turns out to be 0, this quantity becomes 0. So your e to the power 0 becomes 1 and your probability maximum comes out. Okay, at x equal to 0, because over here this quantity is always going to be negative, that's why it is happening. Okay, and because it is x square by a square, so this quantity is always going to be negative, because x square over a square is always going to be positive, and when you apply minus sign, it is always going to be negative. And when it comes in the denominator, in this form, it is something of this kind, that you are multiplying with something like this, 1 over 100 suppose. So if you multiply something with 1 over 100, its value is going to reduce. Its value is going to reduce for sure, right? So simply that means that x equal to 0 will yield you maximum probability density. Okay, it will yield you maximum probability density. So basically for x equal to 0, this 1 upon a root pi, and it is basically maximum. Okay, now we will basically draw a graph. Okay, We will basically draw a graph. Let me show you the graph. How will it look like? Okay. Consider it to be a vertical line. Okay. Although it is not looking vertical, but consider it to be a vertical line. And then it will look something like this. Okay. This thing will be in the middle. Okay. Let me erase this. Let me erase this. It will be something in the middle. Okay. Okay. So this is the thing. And how did we know that this graph is going to come? How did we know this that this graph will come? We know this thing from the nature of exponential function. We know this thing from the nature of exponential function because the function which we have got is something of this kind. So it will be symmetrical. Why will it be symmetrical? Because if you put x equal to 1, it will turn into x square and again yield you 1. And if you put x equal to minus 1, it will become x square and again yield you 1. So on both the side of this axis, this is basically y axis. On both the side of y axis, there will be symmetry. Because if you go x equal to 1 over here and if you go x equal to minus 1 over here, both are going to yield you the same value. Okay. And why is it decreasing on both the side of x? Because as you keep on increasing the value of x over here, as you keep on increasing the value of x over here, the function will keep on decreasing. The function will keep on decreasing because this will go in the denominator. Okay, e to the power minus it is, right? So as it is e to the power that, so you can clearly write it to be equal to like this. Imagine it like this. Okay. When you imagine it like this, as you keep on increasing the value of x, as you keep on increasing the value of x, this value will keep on increasing, and as the denominator increases, the value decreases. So from here it is very clear that on both the side it will decrease. Okay, exponentially it will decrease because it is an exponential function. So that's how we got this graph. Okay, at x equal to plus minus a, now let us put the value of, we have clearly got this, that sigma x comma 0 is equal to your 1 over a root pi, 1 over a root pi e to the power minus x square over a square. It is like this. So at x equal to plus minus a, what will happen? At x equal to plus minus a, clearly you can see this thing, that 1 over a root pi will come. Okay, and when you put a square over a, this will come and it will become 1 over a e root pi. It will become 1 over a e root pi. Now you know this very well, that 1 upon e. Okay, now this quantity, which quantity? This quantity, which quantity? This quantity. Look at, have a look over here. We have found out sigma 0 comma 0. Not sigma rho 0 comma 0 we have already found out. So rho 0 comma 0 has come out to be 1 upon a root pi. So now you can write over here rho 0 comma 0 over e, you can write, right? Because in the place of this you are substituting sigma uh, 0 comma 0 because it is that value. So you substituted it. So sigma, not sigma, rho 0 comma 0 divided by e. Okay. So it will be basically what? Over your 1 over e. 1 over e value is equal to 0.37, right? 1 over e value is equal to 0.37. So it will become 0.37 and so rho 0 comma 0. 0.37 rho 0 comma 0 and 0.37 rho 0 comma 0. You know this very well, that rho 0 comma 0 is the area of maximum probability. So rho max. Okay. So 0.37 rho max. So you can see this clearly, that over here somewhere x equal to a will minus a will lie, and over here somewhere x equal to plus a will lie. Okay. So clearly at a distance x equal to plus minus a, the probability, maximum probability decreases to. So we can write over here. You found out, right? So what you found out? Sigma 0 comma 0 equal to 1 upon a root pi you found out, and sigma not sigma rho. Okay, plus minus 0. Okay. Rho plus minus a comma 0, this value came out to be equal to 0.37 rho max. Okay, so this is basically your rho max. So you can see this thing very clearly from here, that at x equal to a comma minus a, the probability decreases. The probability decreases to 37%. 0.37 rho max means what? 0.37 rho max means 37%, right? So the probability decreases to 37% of maximum probability. Probability decreases to 37% of max probability. So as it decreases to 37% of maximum probability, we can clearly see this thing, that maximum probability will be in what region? Beyond these regions. Okay, let me draw once again. Okay, so beyond these regions, x equal to minus a and x equal to plus a. Over here, over here it becomes 37%. Okay, over here it becomes 37%. Over here it is 100%. Okay, so what will be the area of maximum probability density? Clearly this area is going to be the area of maximum probability density. This area will be the area of maximum probability density. These all these areas over here, the areas over here will have very low probability. Okay, the areas over here will have very low probability. Okay, so this shaded region, the region shaded in green, okay, the green region shows the area of maximum probability. Okay, the green region shows the area of maximum probability. So the particle is most so conclusion we can write over here. So we can write one conclusion over here. Okay, we can write one conclusion over here. The particle is most likely. Okay, the particle is most likely to be found in region of width a on either side, on either side of the origin x equal to 0. So the particle is most likely to be found in the region of width a. I clearly I have shown you this region of width a. Okay, region of width a, region of width a on either side of the y-axis. Okay, on either side of the y-axis. This is y-axis. So on either side of the y-axis, this side also and this side also. Okay, for a width a, or we can say either side of the, instead of either side of the y-axis we can also say either side of the origin x equal to 0. Okay, so either side. Okay, this is x equal to 0, right? This is x equal to 0. So on either side of x equal to 0, this is going to be the case. Okay, on either side of x equal to 0, the particle is most likely to be found. Okay, so this is what was that is all for the discussion for today. That is all. Okay, so thank you very much. Jai Hind, Jai Bharat. अपना ख्याल रखें. Okay, in what region of space? This was the question, right? Most likely to be found. I had already told you. In what region of the space the particle is most likely to be found? And that is the highest probability region. So we have successfully found out that. So thank you very much.